Well, let's take a look at a couple of examples. You see, in this circuit, there is a battery and a light bulb all in one loop. See? This is called a series circuit.
Series? Okay.
It doesn't matter where you place the ammeter because the number of electrons will be the same all the way around. They have nowhere else to go. But if we change the circuit and put a split in it, like this, it's called a parallel circuit.
Hang on, you're going to have to go through that again.
Okay, in a series circuit, the electricity has to pass through all the components, one after another, in series. But in a parallel circuit, the electricity has to pass through some of the components at the same time, in parallel.
So in a parallel circuit, the current splits to flow through the different parts of the circuit.
Yep, and in a parallel circuit, you can work out how much current goes into each part of the circuit. See, before the current is split, the ammeter reads 4 amps, but the amount of current going into each light bulb is half that amount.
2 amps. So that means that half the electrons flow to the first light bulb and the other half the electrons flow to the second light bulb.
Yeah, and later on in the circuit, the two currents combine again, giving us the same amount of current we had at the beginning of the circuit.
4 amps.
Exactly. Now let's have a look at the voltage. If the voltmeter reads 0.5 volts across the light bulb, then that's how much energy the electron has lost passing through the light bulb.
So when the electrons go back to the battery, they need to receive 0.5 volts to fill up again.
Exactly. So a voltmeter around the light bulb should read the same as one around the battery.
And it does. Excellent.
Okay, now let's add another light bulb.
In series.
That's right, because the electricity is able to go from one light bulb to the next. It's still a series circuit.
Okay.
Now there are 2 light bulbs. The electrons transfer half their energy at the first light bulb and then half their energy at the next. This should mean that if we use the same battery, the voltage across the battery is 0.5 volts, but the voltage across each of the bulbs is 0.25 volts.
0.5 and 0.25 volts. That's the correct answer.
I'm glad to hear it. Now let's think about what would happen if the 2 bulbs were in parallel.
One parallel circuit coming up.
Thank you. Well, there are 2 bulbs here, but each electron only passes through one bulb as it flows around the circuit.
So does that affect the voltage?
Oh yes, it certainly does. You see, each electron receives 0.5 volts of energy from the battery and transfers all of that 0.5 volts to just one of the bulbs.
So there are fewer electrons going to each light bulb in the parallel circuit, but each electron has more energy, so both of the bulbs have more energy and are brighter.
Yes, I'm glad to hear the light bulbs aren't the only bright things around here.